Good day, engineers! Para sa video natin ngayon, ang i-discuss natin is sample problem number 1. So, this is for the analysis of T-beams. So, simulan natin yung sample problem number 1 by knowing kung ano yung gusto niyang ipahanap. So, from the plan shown, which is ito, beam 3GB-2 having a dimension of 300 mm by 450 mm is to be analyzed at mid-span where it is reinforced with 4 diameter 25 mm bars as tension reinforcement, and the beam is monolithically casted to a 120 mm thick slab. It is also reinforced with diameter 10 mm stirrups. Determine the following if all the surrounding beams have a dimension of 300 mm by 450 mm and the columns have a dimension of 300 mm by 500 mm. So the F prime C is 27.6 megapascal and Fy is 414 megapascal. So we have to determine the depth of compression block, the actual compression steel stress, and the ultimate moment capacity of our beam. So, una nating gawin is to check the clear spacing of the 4 diameter 25 mm bars kung kakasya siya sa single layer lang. So, kung kasya naman siya sa single layer lang, so, pwede natin gawing single layer singly reinforced beam to. So, to check the spacing, we have here, or kailangan natin syempre yung clear cover kasi niyan. So since ito yung 3GB-2 at kung mapapansin natin, that is an interior beam na. So ibig sabihin nasa loob na siya nung beam natin or nung structure natin. So ibig sabihin hindi naman siguro siya masasubject to the change of weather conditions. So, ibig sabihin, pwede natin sigurong kunin ito as a concrete clear cover of 40 mm, which is stated in the code. So, from this one, we could have the check of spacing, which is S is equal to the B minus dalawang concrete clear cover minus 6 na diameter ng stirrups minus n minus 1 times the diameter of the bar divided by the n minus 1. So our spacing coming from this one will be 300 minus dalawang clear cover which is 40 minus 6 na 10 kasi diameter 10 mm stirrups yung gagamitin natin minus n is 4 minus 1 times ang diameter ng bar natin is 25 divided by 4 minus 1. So, our clear spacing coming from this one will be equivalent to a value 85/3 mm. So, kung kukunin natin yung exact values in decimal ng 85/3, that is 28.3333 mm. So, that is greater than our requirement which is 25 mm. So, remember, ina-assume natin dito na yung diameter ng aggregate na gamit is a 3/4 inch diameter of aggregate. So, kaya yung minimum requirement natin na ng spacing is 25 mm lang. So, we can conclude that this is a single layer beam. And before we analyze, syempre, since this is a plan, so since this is monolithically casted dun sa slab natin, so yung beam natin will produce either an inverted L shape or a T-beam itself. So, since interior beam siya and it supports two slabs, so itong slab na to on the left and this slab on the right, so ibig sabihin we can have here AT beam. So, kunin natin siya sa AT beam. Ito. So, kailangan natin ng value ng overhanging flange width or OHFW, which will come from our code provision. So, ito yung code provision natin for the analysis of T-beam. So, since this is a T-beam, ang kukunin natin is itong provision na to. So, which is 8H, SW over 2, ln over 8. Yun yung T-beam natin. Or yun yung provision natin for the T-beam. And by the way, since hindi nasama dito yung, or since stated naman dito yung thickness ng slab natin, which is 120 mm thick slab. So, magagamit na natin yung equations or yung provisions for our T-beam. So, syempre, kakailanganin natin yung effective flange width, which will be coming from this code. So, daw tayo dun sa first provision. So, our effective flange width according to the first provision will be 8H, and that is each side of our web. So, that will be BE is equal to BW plus, since each side, and we have two sides, which is ito at ito, so that will be 2 times 8H, and that is BW plus 16H. So, that will be a value 300 plus 16 times the thickness 120 mm. So, from this one, we have an effective flange width equivalent to 2,220 mm. So, hindi pa natin pwedeng i-conclude na ito yung effective flange width. Punta tayo on the part of the second provision, which is sabi dito, we get SW over 2. And as you can see dito sa plan, so SW is the clear distance to the next web. So ang next web natin will be this one and this one, which is 3GB-3 and 3GB-1. So kailangan natin kunin yung clear span between them. Kung mapapansin nyo, yung support to support distance or center to center distance nila is equal, which is 4 meters. So, ibig sabihin, i-check na lang natin kung mag-equal yung values nila kapag dineduct. So, sabi naman kasi dito, ang surrounding beams have a dimension of 300 mm by 450 mm. Remember, ang ibabawas natin sa beam na to or sa span na to is kalahati nito, or yung kalahati ng width nito at kalahati ng width ng mismong i-analyze natin na beam. Yung i-analyze natin na beam is 300 mm din, at yung mga beam na surrounding sa kanya is may width na 300 mm din. So, ibig sabihin, pag kinuha natin si SW, that will be equal. So, kunin natin yung SW. So, sabi dyan, SW is equal to 4,000, which is yung center to center distance, minus 300. 300 kasi kalahati nito tapos kalahati din dito. And syempre, yung sa kabila, kalahati din ito at kalahati din ito. Para silang 300. So, they have the same value. So, we can say na SW lang siya. Hindi tayo magkakaroon ng SW sub 1 and SW sub 2. So, we have here 3,700 mm. And from our code provision, we have an effective flange width equivalent to BW plus SW over 2. And since this is each side of the web, so this will be multiplied by 2. So we have here BW plus SW. Then, getting the effective flange width by substituting the values, we have 300 mm plus 3,700 mm that will be an effective flange width equivalent to 4,000 mm. So, that will be the second provision. Hindi pa natin siya pwedeng galawin kasi meron pa tayong third provision. Our third provision is the ln over 8. So, for our ln over 8, we have here BE is equal to BW plus ln over 8. And since this is each side of the web, so times 2. So, that will be BW plus ln over 4. So, yung ln natin for this given, syempre, yung clear span length. So, ibig sabihin, from this one, since ang given sa atin is center to center distance of column, so, kailangan natin ngayon i-deduct kung ano yung support ng beam na yun. At ang support ng beam natin is a column. And sabi dito, ang dimension ng column is 300 mm by 500 mm. So, ang kailangan natin ibawas is kung ano yung nagpuputrud na dimension. So, ang kailangan natin ibawas is yung mas malaki kasi along dun sa ina-analyze natin yung mas malaking dimension. So, ibig sabihin, dapat kalahati dito at kalahati dito yung ibawas natin. So, dun tayo sa 500 na side. So, syempre, mag-iiba yung analysis niyan kung ang nangyari, humiga to ng paganyan. So, since nakatayo naman siya ng orientation na paganito, so, ang ibabawas lang natin will be yung 500 mm divided by 2 at 500 mm divided by 2 sa kabila. So, syempre, that is still 500. So, we can have here the value of ln. So, for dln, we have that is equal to 4,200 minus 500. So, we have here a value 3,700 mm. Then, substituting this one to our equation, we have 300 plus 3,700 over 4. So, that will be a value of BE equivalent to 1,225 mm. So, ito na ngayon yung ating effective flange width for the third condition. And sabi ni code, choose the lesser of the three. So, the lesser is the BE, which is, so therefore, that will be BE is equal to 1,225 mm. Ito na ngayon yung ating effective flange width na gagamitin natin for our analysis. So, before we go to our analysis, syempre kunin muna natin yung mga necessary values kagaya ng AS, ng DT, and ng D. So, sa AS natin, syempre, papasok doon yung 4 times pi over 4 times 25 squared, which is equivalent to 625 pi. On the part of the effective depth and the DT, so, same lang sila kasi we have a single layer beam. So, that will be DT is equal to D. So, that is 450 minus 40 minus 10 minus 25 over 2. So, we have a D and DT equivalent to 775 over 2 mm. So, yan ngayon yung mga properties na kakailanganin pa natin for our analysis. So, ngayon, the next one will be kailangan nating i-consider yung part nung area ng concrete kung saan siya kung saan papatak or saan mapupunta yung depth of compression block natin. So, to check kung nasaan si depth of compression block, we will be using the equilibrium equation C is equal to T, and yung compression side will just be 0.85 F prime C AC is equal to AS FY. So from this one, substitute natin yung values or arrange muna natin. So AC will just be equivalent to that is AS FY over 0.85 of RF prime C. So that is AS will be 625 pi times 414 divided by, so FY natin is 414 divided by 0.85 times 27.6. So the area of concrete from this particular calculation will be 34,649.919. This is in mm squared. Ngayon, para malaman natin kung saan papatak si depth of compression block, we need the value of the area of the flange. The area of the flange will be, syempre, yung BE natin is 1225. Ita times lang natin yan sa 120. So that will be 1225 times 120. So the area of the flange will just be equivalent to 147,000 mm squared. And this is far greater than sa nakuha nating A sub C. Therefore, our depth of compression block A will be lesser than the thickness of the slab or the height of our flange. So now we can proceed to analysis of a rectangular singly reinforced beam having a breadth of B sub E. So kunin natin lang yung diagram na yun. So this one. So syempre, this is just the same analysis as a singly reinforced beam or a rectangular singly reinforced beam. So proceed tayo on the part of C is equal to T. So that will be 0.85 F prime C ABE is equal to AS FY. Okay lang naman na yung ABE is equate nyo dito. Basta kompleto yung decimal nito para hindi masyadong malayo yung naisasagot niya. Pero kung 2 to 3, last 2 decimal lang yung discrepancy nila, maybe okay yun and acceptable. So that will be equal now to A is equal to ASFY over 0.85 F prime C BE. So that will be equal to 625 pi times 414 divided by 0.85 F prime C or times F prime C is 27.6 times 1225 na BE. Our A coming from this calculation will be equivalent to 28.2856. That is in mm. And our C will just be equivalent to A over our beta 1, which is, ang A natin is 28.2856 divided by the beta 1. So ang F prime C natin is 27.6, which is lesser than 28. So that is 0.85 yung beta 1 natin. From this calculation, we can get a value of C which is equal to 33.2772. So this will be in mm. So hindi pa natin sure kung ito talaga yung depth of compression block natin and yung C. So, to check, we have here yung equation for the steel stress, which is equal to 600 times D minus C over the C. So, that will be equal to, so si 600, times natin sa 775 over 2, which is yung effective depth, minus yung C natin, which is 33.2772, divided by yung C natin na 33.2772. So our Fs for this calculation will be 6,386.7657. So this is in megapascal and this is far greater than Fy. Therefore, tama yung assumption that the steel yields. And then, A, now, na require sa atin nung problem is ito, since na-prove naman na natin na steel yields. And sabi pa dito sa problem, we need the actual compression or tension yan. So, wala kasi tayong compression side for this one. So, this should be tension. So, that is the tension. Steel stress. So, for our tension, steel stress, syempre, that will be, the actual is this one. So, that is 6,386.7657 megapascals. So, now we can proceed in getting the ultimate moment capacity nung beam natin. So, to get the ultimate moment capacity for our beam, syempre dadaan muna tayo sa pagkuha ng net tensile strain para makuha si reduction factor. So, we have here yung epsilon sub t which correspond to 0.003 dt minus c over the c. So, that will be equivalent to 0.003 times 775 over 2 minus 33.2772 divided by 33.2772. So, our epsilon sub t now will just be equivalent to 0.031934, which is far greater than 0.005. Therefore, our beam is ductile and yung phi natin will be equivalent to 0.9. So now we can proceed in getting our ultimate moment capacity. So kunin natin yung diagram. So ito, syempre pwede natin kunin yan on the tension side or on the compression side. So for this one, kunin ko on the tension side. So that will be Mn is equal to As, and since yielding, that should be Fy times d minus dA over 2. Same as a rectangular singly reinforced beam. So that will be As is 625 pi times Fy is 414 times the effective depth is 775 over 2 minus dA, which is 28.2856 over 2 times 1 over 1000 squared. So our nominal moment capacity coming from this one will be 303.4973 kilonewton meter. And after getting this one, proceed tayo sa ultimate moment capacity, which should be the reduction factor times the nominal moment. So that will be 0.9 times 303.4973. So that will be a value equivalent to the ultimate moment, which is 273.1476 kilonewton meter. So this will now be the ultimate moment capacity nung beam natin for this sample problem. So that will be all for the sample problem number 1. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.